Dear ladies and gentlemen, we will go forward for our next talk. So please, if you have interest, just come here to the auditorium for the talk of Jörg Riedel. He belongs to the legal metrology part of Niedersachsen in Germany. And he will talk about effects of mobility and energy transition on legal metrology. So please don't think that the other things are not legal, but this is a special kind, a small joke. We all make a very good legal job, so please start.
Thank you for the kind introduction, Mr. Professor Hackel. So from my side, it is a pleasure for me to give you my presentation with the title Effects of Mobility and Energy Transition on Legal Metrology. So my name is Jörg Riedel and I'm from Landesbetrieb Mess- und Eichwesen in Lower Saxony. And first I will give you a briefly overview about the Mess- und Eichwesen. And I think you should know where I come from and what I deal with. And before I give you the overview, I will start with my presentation, just with a simple question: why the mobility and energy transition at all? So the answer is clear. Because of climate change, that brings us to another important question: what does the mobility and energy transition consist of? And this question focused on aims and strategies which were created by European Commission and the government of Germany. And these strategies and goals have effects on legal metrology. And regarding to the mobility transition, I will show you how we do the test of electricity charging stations and hydrogen dispensers. And regarding the energy transition, I have to talk about smart grid and smart metering. And before I end, I will give you a summary. Okay. MEN is a shortcut for Mess and Eichwesen, Niedersachsen. So it is a verification authority and a state enterprise divided in 5 operating centers with 9 locations, 150 employees, do over 200,000 tests and verifications per year at 150 different types of measuring devices and meters. And so that's why I'm looking on the transition from the perspective of legal metrology. Okay, why the mobility and energy transition at all? So because of industrialization, and industrialization means emission of greenhouse gases. And here you can see a picture of the emission over the time. And in the end of the Second World War began the start of emission. And until now, you can see the increase, very high increase. Until now, we can see and say that the half of the emission is driven by China and other countries of Asia. So emission of greenhouse gas brings an impact of global warming, and here you can see the mean air temperature at the Earth's surface over 4 years, from 2015 to 2019. And interesting is that regional differences are on the map. So look at Brazil. You can see Brazil has 2-3 degrees over the mean air temperature. Also Europe and Asia and Antarctica. And global warming means climate change. And climate change means more frequent local extreme weather events. And so we have only 3 big events in this year: Germany for 2 weeks, in Bavaria, a big flood, and also in Brazil and Russia, and in India 2021. So what can we do to interrupt the emission of greenhouse gases? And there are some goals and strategies of various institutions. First of all, I have to say, or to announce mean Green Deal by the European Commission. It is a package of political political strategies, yes, for European climate neutrality by 2050, and Germany has developed also a strategy of system development for climate neutrality by 2045, and there are different other strategies for of transformations of carbon-free companies, and for hydrogen, and various strategies and laws of the governments of the federal states of Germany. And all these goals and strategies and laws form the framework for the energy transition and mobility transition. So what you can see here is a puzzle of 4 pictures, and the left side represent the power side by wind and sun and plants, and the right side represent the consumer side. The consumers want to drive with vehicles, and therefore they need current and also hydrogen fuel if they use fuel cells vehicles, and they live in cities, and therefore they need also current and heat and gas to make heat, and that means they have to meter the quantums, and that means we have to install smart metering system. And all these 4 pieces, all these 4 pictures, that's the task to evaluate, to implementate a smart grid. It means a communicative connection of the actors in the energy system, and that will bring us to an integrated data and energy network. These bring us also effects on legal metrology in terms of legal compliant commercial trading of energy. That's important. And concerning the distribution of energy, respective to the intelligent metering system, we have to talk about smart metering. And concerning mobility, I will show you method how to test the electrical charging stations, and also to test the hydrogen dispensers. I will start with hydrogen dispensers, and then I will come to the electricity charging stations, and finally I will talk about smart meter and smart meter gateway, of course. Okay, when you have fuel cell vehicle and you want to drive through Germany and Europe, you need an infrastructure of dispensers to fill up your car with hydrogen. And the company who installs these dispensers is H2 Mobility. In Germany, they had installed 87 dispensers to fill up cars by 700 bar, and 14 until now 14 dispensers for trucks to fill up by 350 bar. And it is quite easy. You take the pistol of the dispenser and put it on the car, and then you fill up the car, and it takes only 5 minutes, and then you can go and far away, quite easy. And what we do to test the dispenser, we put in line with the dispenser, in line to the car, another flow meter. We use a Corus flow meter, and what we do is to measure in line with the dispenser the same quantity of hydrogen. And then we do the comparison between both values of the dispenser and our flow meter, and if the deviation is less than 2%, the dispenser is quite well. And it is a big advantage here by this method, because we test under real conditions. And what we need for our reference measuring systems, system, we call it so RMS, is in metrological traceability, which is developing now from the PTB, and it should give us the hydrogen quantity, and that's necessary for the traceability. Otherwise, we have no chance to do a right measurement, of course. Okay, now I will show you the method for testing of charging stations with alternating current. It is the same method like we do it with hydrogen dispenser. We use an electricity meter for AC and put it in line between the charging station and the car. And then we do the comparison of the values. And here in this case, there was no car. So they use, my colleagues use a blower, and that was also okay. You need only ohmic resistors, and it could be a battery of a car or for example here, blower. And but what you that's the way of when you test charging stations for alternating current. But in the field we find 60,000 charging stations, approximately 90,000 charging points, and most of them work with direct current and up to 500 kilowatt. And when we want to test this charging stations, it is a little bit difficult, because there's a specification for DC charging stations. To test them, it is necessary to do the measurement of energy quantities at low charging current and high charging voltage, as well as high charging current and low charging voltage. So the adjustability of voltage and current is required for a test. And what you can see here on the left side is a picture. You see of an current and voltage, and it depends of the battery of the car. And so there's no possibility to adjust the voltage and the current. But with Elvis, it is. Elvis is the shortcut for electric vehicle charger inspection system, and Elvis is a PTB development, so far only available as a prototype. Elvis enables the testing for charging stations for AC, also for DC, because they use the principle of phantom power. And when you think when you think about phantom power, then you think also, or you have to think also about alternating current, and it is a little bit difficult. So we are happy from the side of the verification authorities in Germany that PDB did this development, and I hope PDB will find a company who will produce this trailer in series for the authorities in Germany. Okay, at this point, I will also talk or give you a notice that it is also possible to use trucks by overhead contact line for power from 600 kilowatt at 1000 volt. And to test these trucks, it is quite easy because you have to test only the electrical meter, but it is not easy so you have losses of current because of the pantograph, and you have to clarify where is a border against the customer or the consumer. Here is a truck driver and the company who gives the electricity. Okay, so now I would come to smart metering and smart meter gateway. It is necessary for an intelligent metering system and for energy distribution. And this picture is, and the second, the next one also says what is to say. When you see at the picture and look at the upper half, when you look at the right side, there's the energy production, energy generation. And in an ordinary way, now we have the situation that the current will come from the energy production side, left side, to the right side where the consumer is. And the consumer has the meter, and for an intelligent metering system, we need also data transfer. And because the current is green and is not always present, and to bring the current to the consumer who needs the current, data transfer is necessary, and therefore we need a smart meter gateway. Smart meter gateway is a central component for smart metering system, and the goal is legally compliant energy billing. And it is a little bit complicated because the consumer brings also energy in the network, and by heat pump and own solar panel and so on. So let us check the task of the smart metering gateway. The smart meter gateway collects data of consumer. The smart meter gateway calculates differential quantities from the meter regardings. It combines the quantities with tariff information, and receives and forwards changes to the tariffs, and receives and transmit signals to control, maybe the heat pump, and send and receive data to the network operator, and from the network operator, and the network operator sends the data to the consumer for controlling, and a legal possibility to check the accounts is acquired because otherwise the consumer has no chance to recognize what is happening. So let me give you a summary. I told you something about strategies from European Commission, Green Deal, German strategy of system development for climate neutrality by 2045, and therefore it needs a smart grid. Smart grid is an integrated data and energy network for communicative connection of the actors in the energy system. Important is that it has impact on metrology in terms of legal, secure, commercial energy trading. And concerning to mobility, I told you something about the test method to verify and test electrical charging stations, and also hydrogen dispensers, and to have an intelligent distribution of energy. We need a smart metering and smart meter gateway, and the goal is a legal compliant billing of energy quantities in accordance with the German Measurement and Verification Act. We call it Mess- und Eichgesetz. And so I'm glad that I finished the presentation.
Yeah, thanks a lot for your very nice presentation, Jörg. It was great. Are there any questions from the auditorium? But I have a question.
Oh.
Smart meter gateway. I think this is a very important part of the whole system. And what do you think about that every German household will get such a smart meter gateway? Because I think there we have the possibility to save a lot of energy. For example, for intelligent washing machines, that they are washing in the night and not in the morning when a lot of power is needed in the network.
Yeah.
And so on and so forth. That's the first question. And the second question is, what about the other countries? For example, in Europe, do they have such things? Do you know something about it?
I don't know about the other countries, sorry, but that's an interesting question. And important is that the smart meter gateway fulfill the requirements of the European Directive for Measurements, and because the data are very sensitive, personal data, and the smart meter gateway has to be certified. It has to be certified, and so yes, it is important to have a legal check, and you, as consumer, you have to trust on the smart meter gateway, and also on the smart meter itself. And when the smart meter gateway will be wrong, then you will pay too much, and then you cannot trust the smart meter gateway. And everybody will in connection with this gateway, and then when nobody can trust the gateway, it is horrible. Yes.
Yes. Yeah.
Yeah, if you don't mind. So the smart meter, will it also work? I know in the United States there's this idea that you could have an electric car that's charged, and then when there's high demand, some of that energy from the car's battery can actually go back to the grid.
Yeah.
And provide sort of, emergency power to the system. So my question is, does such a smart meter work in both directions, and is that part of the plan?
Yes, it's quite easy. It works in both directions, and this situation is is possible also here in Germany, so that you can use the current from the battery of your car and put it in the grid. Yes, of course. Yeah, there's no problem. But to manage, to do the intelligent management, that's the challenge, because the current, the green current, is not continuously present.
So there's a lot to do, and I think it's a big potential for saving energy and saving carbon dioxide. So thanks a lot for your very fantastic talk. Now we will switch to the next person.